All right.
Okay, hey, welcome back, everybody. Welcome to day 4 of String Week. Happy Thursday, or I guess Friday, depending on your time zone. This is AP Computer Science A Live Lessons. My name is Rob Schultz from Bellbrook High School in Bellbrook, Ohio.
And I'm Jill Westerlin from Hoover, Alabama, Hoover High School. We're so glad that you're with us. Here's our map of learners, less 2 new pins to drop. Actually, on both sides, we kind of get to bookend when I update this. We have a pin to drop in China and a pin to drop in Kazakhstan. So that's kind of fun. So that's exciting when we get mail from places far away. It's also exciting to get mail from nearby. So all right, let's go through quickly the exam information that we have, and I have a couple of post-it note things over here to throw in too. You're going to have a test on May the 15th. It'll have 2 questions. The first one is 65% of your score, and you'll have longer to do it, 25 minutes, and it will either be array or array list. And we're actually sandwiched in between that. If we were the Oreo cookie of lesson plans this week, we're the white filling right now. Last week we did arrays, which was 1 cookie, and next week we're doing array lists, but because strings are such a part of a lot of these questions, we sandwich strings in the middle. So you're at the right place to hear about implementing arrays and array lists and strings. And then your second question will be methods and control structures, a little bit shorter question and 35% of your score. So keep May the 15th on your calendar, and for all the information, go to AP Central Coronavirus Updates. All right, so we got some good mail from yesterday. I actually have, like I say, a few notes over here. This is from Nandika, and she wrote her own code. I assume it's a she, but I don't know. I'm thinking it's a she. Love the comment. We get real excited when we get encouragement. Wrote her own code for code word checker yesterday. I really like her solution better than the Canonical solution because she declared a new variable, location of forbidden, and then use that in the return. I just like this. It's different than the one that College Board puts out. It's different than Mr. Schultz's, and it's good. So I love that you spent time coding it.
So I'm going to
You want
jump
to
in
add
here real quick too. This is very, very similar to the canonical solution, like
anything?
Mrs. Westerlin said, and I also like it better because of the use of this variable up here, location of forbidden. One of the things I forgot to mention yesterday as we were working through, we had a student write, I believe it was Nate, that wrote several days ago that asked if the solution for a problem has to specifically match the canonical, or what happens if it's a little less efficient. And I meant to address that yesterday. The one that I kind of guided us through yesterday, I purposely made the solution a little off from the canonical and maybe a little less efficient, just to kind of demonstrate the point that it still would have got it still would have earned all of the points on the rubric. And in the process of doing that, we kind of got in a hurry.
Right.
We had Kong that pointed out that there was a logic error, that our code wouldn't have gone all the way to the end. So before we kind of address Kong, and his comments, I wanted to point out that I love it. Obviously as teachers, we all as teachers try and avoid making the little goofs, but when we do, I love it when students catch us and point it out, because it tells me as a teacher that, one, the student is paying attention and they know their stuff, and then 2, it also gives us an opportunity to hit some talking points, like, for example, making sure that you aren't rushed. And yesterday we kind of fell into that trap, and I take the heat for it. We got a little sloppy.
Well, I was the writer, so there's no
Well, and
telling.
I was the eyes, behind the rider. So
Yeah,
we'll have to arm wrestle over who takes the heat for that
that's
one.
right.
But
But we're
um,
persistent. We're not
yes.
perfect. We're persistent. So that's the
So yeah,
motto.
so apologies for the goof for those that caught it yesterday, or I guess even for those that didn't. But definitely kudos to you pronounced it Nandika.
Yeah, I think so.
I think that's how you pronounce it.
Nandika.
Apologies if we're pronouncing that
Yeah.
wrong, Nandika. And kudos to Kong for catching our little goof.
But I
Um,
also like this question about the data set. He's asking about, will the AP readers, the graders, check our code on a given data set? And the truth is no. I mean, they're going to check the code against what's going to work. you
Yeah.
know?
Yeah, and I think I've mentioned this a couple of times as we've looked at
Hmm.
different free response questions. Those examples are just examples. They are not the end all be all that you're writing the code for. So if they give an
Right.
example that says it's supposed to work, we as programmers need to make sure that we're checking all of the different possibilities. And in the case of yesterday, looking specifically at boundary conditions. Does the keyword occur in the middle? Does it occur first thing? Does it occur last thing? And anywhere in between, we need to make sure that the code's going to work
Hmm.
for all of them. So not just the examples that were given.
Yeah.
So
Very good.
gold star.
I
Um,
know.
to
We
to
should
con.
have candy to give you, but we're
Yeah, I
constricted by
know.
that.
I
The
wish.
other note that we got, a really a long note, and it may be a second note from Trevor, recommending some different options. If it comes up once we know more about the exam submission, we will be recommending different options. So, if you're listening, Trevor, I love your detail and I love what you told, and I'm going to personally look at it all, but we'll share it when we can.
Yeah.
So, all right. So, like I told you, we're in string week, which is an important week. And today you're going to really be dazzled by, not bedazzled, but bedazzled by Mr. Schultz's example that he has built for y'all. We talked about it over the weekend, and he just got, I guess, inspired and made something super cool that y'all are going to be able to see. And then we'll roll into 2017 number 3 and look at that question. But before we do that, we're going to finish the delimiters question from yesterday. I hope you're taking notes. If you are a note follower of mine, I think yesterday I put about 6 or 8 pictures of new notes pages related to this week's work in the journal folder. I would love it if you would take your own notes from the lessons instead of recopying mine. But if you feel more comfortable recopying mine, I think it still builds that concept in your head. You're thinking through what you're writing down. So please do that. And we modeled writing code out and taking pictures yesterday. So I hope that was helpful too. And here we go with delimiters, part B.
Okay, so yesterday we started the delimiters, the 2019 question 3. We worked through part A. So if you missed that, feel free to step back, watch the video from yesterday, so that you understand part A. Today we're going to pick up with that, and we're going to look at part B, which is to write a method called isBalanced, which is going to return true when all of our delimiters are balanced. And again, I don't want to take a whole lot of time to go back and kind of rehash what the question does, but there is one example. I think in the actual question they give like 4 examples, and I copied one. But we're looking at delimiters in a string. In part A we wrote a method that would create that would take all of the open close delimiters and put them into an array list. And then now we're going to write a method that's going to tell us whether or not our delimiters are balanced. In other words, for all of our open parentheses, we have a closed parenthesis and they're all in the right order. Or for every delimiter that you see in the example, everything opens and closes in the right order and everything works the way it's supposed to. So yesterday our theme was kind of looking at what we would do if this was a free response question and kind of following some steps. So I'm going to kind of skip through the reading part and go straight to the design part where we kind of sketch out a rough sketch of what our solution is going to do. To make sure that this solution works and that our delimiters are balanced, the first thing we have to do is we have to have a loop that's going to traverse delimiters, and delimiters is a required keyword. That's why I underlined it. If the delimiter that we're looking at is equal to open del, which is an instance variable, so I have that one underlined, we're going to add one to a counter. Otherwise, we're going to add one to a close counter. And because our delimiters list from yesterday has to contain only open delimiters or closed delimiters, we know it has to be one or the other. So we're okay there. As I was kind of writing this out, as I kind of practice what I try and get my students to do, and I was kind of sketching this out, I got to a point where I needed a variable open counter that I could add. Well, again, that's kind of my reminder that, don't forget, we got to go back to the beginning. We've got to declare and initialize these counter variables so we can throw those in. And then inside the loop, if ever the close counter count is greater than the open counter count, okay, the open delimiter count, then that means we're unbalanced. We have an extra close delimiter that doesn't go with an open. So at that point, we can immediately return false. We know that they're not balanced. And outside the loop, so that's the end of our loop, but outside the loop, after we've gone through and we've counted all of them, if open counter is equal to close counter, then we know that they have to be balanced. We can return true, otherwise we'll return false. So now that we have our little roadmap, then what I would do is I would slide that piece of paper over to the side, and I would take a clean piece of paper and I'd start writing out the code. And really, we can just kind of follow this exactly like a map. And I kind of set it up so that we can kind of trace our way through here. The first thing we have to do is declare and initialize our variables. And then we have a loop that's going to let us traverse delimiters. We're going to get a string from delimiters. So if our string happens to be equal to open del, we'll add 1 to the counter for our open counter. Otherwise, we'll add 1 to close counter. Inside the loop still, we're going to say if close counter is greater than open counter, then we return false. And again, by kind of doing it this way, we have a nice little map to make sure that we catch everything that we need to catch, hopefully. So we get to the bottom. If open counter equals close counter, then we return true, else we return false. And there's our code for our is-balanced method. If you've never done a little project like this before, this is kind of a fun one. Sometimes if I have students that are ahead in class and I want to give them a little challenge problem for a little extra credit, I'll give them something similar to this where they have to take a string and then a string consisting of nothing but open and close parentheses, and they have to determine whether or not the parentheses are balanced and that they open and close correctly. So it's kind of a fun one to play with if you've never actually tried it. So how did you do? Hopefully, hopefully you came up with a good solution. Make sure when you work on free response questions, go out and check the canonical, check the scoring guidelines. We're gonna spend more time down the road looking at free response questions and digging deeper into how to look at the canonicals and the scoring guidelines to kind of check your work as you go. So feel free to check those out. Okay. All right. So today, we're going to focus specifically on developing algorithms that use strings and writing program code to create objects of a class and call methods. Those are a couple of our learning objectives that we're going to get into. So for some prior knowledge, a knowledge of data types in Java is always a good idea. Knowing how to create string objects, knowing the basic string methods that are part of the Java subset. And I am going to preface by saying there are a lot of ways we could do what we're about to do. I'm going to try and keep everything in the subset. So if something pops up that I see a different way we could do it by going outside the subset, I'll mention it. But the code I'm going to use is going to stay within our subset. Okay. So Mrs. Westerland kind of mentioned that earlier this week, maybe even over the weekend, when we were talking about different ideas of things we could do for strings, we were talking about yesterday and the fact that we were going to tag team the lesson. And I believe you were the one that made the comment that I would be Pat Sajak and you would be Vanna White.
That's right.
And that kind of immediately clicked this idea that, hey, we could write a little spin-off of Wheel of Fortune. So what was it you were calling that? Spiel of Fortune? So this is our Spiel of Fortune game, okay? And we're actually going to code this in just a couple seconds, but I kind of wanted to run through how it works. So we have a string, okay? And the letters of the string are represented by asterisks. And when someone guesses a letter, hey, is there an A? Then we redisplay the board, but we're going to show where the actual letters that have been guessed are. So we have a string that keeps our phrase. We have a second string that keeps our guessed letters. And every time a letter is guessed, we add it to our guessed letters, and then that one becomes okay to display in our phrase, okay? So then somebody says, okay, how about an S? Well, now we've got ACS as our guest letters.
Is anybody screaming the answer at home already? Winning the 5,000 or the 25,000?
I don't know. I hope so. Wait, is it APCSA rocks?
Of course it does.
Of course, yeah. Okay, so that's the main idea of how the game is going to work. Okay, so we're going to write a little game to simulate that. So first thing, again, kind of staying with this idea of maybe designing things out a little bit, I want to make a quick list of the things that we're going to need to do this. So first thing we need is a string to keep track of our phrase. We need a string to keep track of the guessed letters. And because we have two instance variables now for this class we're going to write, we need a constructor to initialize them. We need a method that's going to display the phrase in whatever form we're going to display it, whether it's the asterisks or the actual letters. And then we need a method that's going to let us guess a letter. Okay, so if we were to sit down and kind of take a look at how we would design this out, okay, we've got our instance variables and we've got our constructor. We're going to have our display phrase method, which is going to have to traverse the phrase. We're going to have to get a letter. So as we go through, we're going to get one letter at a time. We're going to have to determine whether or not the letter that we picked up is in our letter list, our guessed letters. And if it is, that means it's already been guessed, so we can display it. And if it's not, we're going to display an asterisk in its place. Okay. The other method we need is we need a method that'll let us guess a letter. So we'll pass a letter in. It'll add letter to our letter list, okay, our instance variable. And then every time we guess a letter, once we add it to the list, we can just automatically call display phrase. So that way all I have to do is pass a letter to my guess letter. It'll add it to the list, display it, and then I can pass the next letter and so on. So anytime I do one of these, I kind of look at the design just briefly when I'm done and go, okay, have I answered everything? Have I dealt with all of the possible cases? Well, the first thing that popped up as I was looking at this was, well, how are we going to deal with spaces? Because there are spaces actually in our phrase. We don't necessarily want to have to guess a space for it to show up, but we don't want it covered up with an asterisk either. So that's one thing we're going to have to deal with. And the second question that popped up was, how do we do this part? How are we going to check to see if a letter is in letter list? Yesterday, we did a problem that was very, very similar to this, where we did a solution that had to traverse the entire letter list and then compare one letter at a time, substring compared to substring. And that's a little tedious, but it works. There is actually a much faster, easier way to do it, as Nandika kind of demonstrated to us. She was a step ahead of me on this one. So there's our design. Now we're going to go out, we're going to unplug. This is the fun part. And we are going to go to JGrasp, and we're actually going to write some code to do this. If my JGrasp comes up,
It looks good. It's
can you
coming.
see it?
I also learned a new trick in JGrasp, by the way.
Mine does not want to come up for some reason. There we go. Now I got it.
There it is.
Okay, everybody
We're
see
all
it okay?
good. Yeah, we're good.
Okay, so what was your trick in JGrasp?
If you zoom out your screen, you know how you make it larger for us? You can do Control-0 and it'll reset it back to normal.
Really?
Yeah.
I
Fun
did not know
fact.
that.
I know.
Okay. Okay, so I'll have to try that sometime. I went ahead and wrote a little simulator file that will go through and actually create a Spiel of Fortune game for us.
That's right.
And I'm going to walk you through how that works real quick. We have to import Java util scanner because we're going to be getting input from the user. I've got my scanner object KB reader. I've got a couple of different answers we can play with up here. The one I'm going to use for testing is the quick brown fox jumps over the lazy dog. And here's your fun fact for the day. Does anybody know what is significant about that sentence? There's a very specific reason that is used a lot for testing of printouts and that kind of stuff. Think about that for a second, and then I'll give you the answer in a minute. We're going to create a Wheel of Fortune object called game, and we're going to pass our string into it. I'll call the method display phrase, which we're going to write, so it'll actually display the initial board. And then I've got a string user guess, and while user guess is not equal to stop, that's how the user is going to tell us that they're done, we're going to ask for a single letter. If the user does not type stop, then we're going to strip away the first character. We're going to pass that specific letter, that one character substring into guess letter, which will then, as we did in our design, display the board and kind of keep us going. And I'm going to kind of preface this by saying, I didn't put a lot of user proofing or any of that into this. This is, again, just a test and make sure our class does what it's supposed to. I challenge you or urge you, whatever you want to think of it, to take this and expand on it a little bit. There are so many different things you could do with this. You could add, Mrs. Westerland and I were kind of brainstorming some things. You could count the number of guesses, letter guesses. You could do points where they get points for a correct guess and take points away for an incorrect guess. You could add a timer to it. You could user proof it to make sure they can only put in one character at a time. You could make sure that they put everything in as uppercase or lowercase. There's so many different things you could do with this. Okay, so I'm just keeping it basic to kind of keep things moving along. All right. And then at the end, when we're done and the user type stops, then it'll go out and say, hey, thank you for playing. And then we move on and we're good to go. Okay, so let's actually start coding the Wheel of Fortune part. Okay. Oh, I didn't tell you what the significance of the sentence was. So if you look at the letters in the quick brown fox jumps over the lazy dog, every letter of the English alphabet is represented in that sentence. So that's why it was used, or I assume still is used, to test printouts to make sure that all, with different fonts, I would assume, and things like that, to make sure that all of the letters in the alphabet show up clearly. So yeah, I just thought that was kind of interesting.
Another fun fact.
Yeah. So one of the things that my students watching right now, hi guys, they'll kind of roll their eyes because they know that I am a stickler for documentation of code. When I was an undergrad, we had a professor, Dr. Fisher, who taught my COBOL class as a freshman at Miami University. So shout out to Dr. Fisher if you're out there watching somewhere. I'm still listening to what you said, but he was adamant about the importance of documenting your code. You know, making sure that you have header documentation, making sure that everything is readable and indented correctly, making sure that your variable names make sense. So I force my students as part of our rubric. It's 10% of the rubric for every project that they have to document their code. So just so I can say I documented our code, April 16th, 2020, programmer Rob Schultz. This is exactly how Dr. Fisher made us do it too. It's just, this is, you know, obviously Java, not COBOL. Purpose, simulate wheel of fortune. Okay, so there we go. Thanks, Dr. Fisher. All right, so we're gonna start by creating our class. Public class W of F is what we called it. We said that we need two instance variables. So, and we want our instance variables to stay private. So private string phrase and private string guest letters. So this was the thing that Dr. Fisher was always adamant about. Make sure you give your variables a name that as you're looking through, you know, down the road, hundreds of thousands of lines of code, you don't have to try and guess what they are. So I know that a phrase is my phrase and guest letter is my guest. I had a student a couple of years ago that would use variable names like blarg and gack, and I finally had to sit him down and say that he had to stop doing that, because as I was looking through his code, I had no idea what those variables were supposed to be.
Bad idea.
Okay. So we need our constructor, and we said that we need to set our two values. And if you remember from our simulation that I wrote, we were going to pass the actual phrase to be guessed in. So string P, phrase equals P, and our guest letter list is just going to be an empty string at this point. Guest letter. Okay, so there we go. We've got our instance variables. We've got a constructor that's going to take a string, set our phrase, and it's going to set our guest letter string to an empty string. So now is where we start getting into the good stuff. So we're going to write public void display phrase. And we said in our design that the first thing we have to do is we have to actually traverse our string. So int I equals 0, I is less than. My students get mad because I can't type code without saying it at the same time. And we said that the first thing we have to do once we go inside our for loop is we have to actually grab a specific character. We want to do one letter at a time. Now, Mrs. Westerland earlier in the week mentioned some of the string methods that are out there that are outside the AP subset. You know, they're outside the swimming pool, they're down at the beach. So one way that we could do this is we could use character at, and then we could compare characters as opposed to strings. I decided with my approach, I was going to try and keep things in the AP subset. So we are going to say, we're going to create a string that's going to hold our letter that we want to check. So I'm going to call it letter to check. And it's going to be just a one character substring phrase dot substring.
And that's the one, if you have learned anything this week, become friends with substring I comma I plus 1.
Yep, that'll always give us
It
just
comes
one
up
at a time.
constantly.
Yeah. Yep. Okay, so we said that there were a couple different outcomes, and one of the things that I kind of mentioned off of the side of our design is that we have to deal with what's going to happen if it's a space. So let's get the space out of the way up front. If by some chance our letter to check equals a space, oops, there we go, we're just going to display a space. So if our letter is a space, we're going to display a space. Okay. Else, if we have to figure out now whether or not the letter that we've picked up from our string is actually a guest letter, if it's one of the letters in our guest letter list. So this is where yesterday I chose to kind of go through a little bit less efficiently and look at every single character one at a time. But if you think about it, there's already a method that we've talked about in our discussion about strings this week that will do that for us. I can go out and I can say else if guest letter dot index of letter to check. Remember what index of does. Index of gives us the position of a specific letter, in this case, that we would be looking for in a string. And if by some chance that letter, that specific little substring that we're looking for in our bigger string doesn't exist, we get -1. So really, I can check to see if letter to check is inside my guessed letters by just saying if index of equals -1. If I say guessed letter dot index of letter to check equals -1, and that comes back true, that means that the letter to check is not in guessed letter, which means, I can't talk and type at the same time. We want to display the asterisk. It hasn't been guessed yet. All right. And so our third option is if it's not a space and it hasn't been guessed, then that means it has been guessed. So now I can just say system.out.print letter to guess. And there we go. That'll take us through our phrase, picking up one letter at a time and determining how to display whatever it is we need to display. Now, notice that all of our system.out.prints are prints, which means they're going to print on one continuous line. So if we don't do something to deal with that, then that means the next time we call display phrase, it's going to continue on that same line. So just to kind of keep things going from one line to the next, I'm going to put a little print line in that just says, hey, while you're here, go down to the next line. And that's the end of our display phrase method. Okay.
Nice.
Last thing we need, we said we need a, I don't remember what I actually called this method over in my little simulator. Where'd it go? Guess letter. There we go. Okay, so we need a public void guess letter. And we said that we were going to pass in a string, presumably just a single letter. So string L. And this one, there isn't a lot to it. We've already done all of our heavy lifting up in the display phrase method. So really all we have to do with this one is add L, add whatever our little string is that we're passing into our guessed letter list. Make sure I spelled that right. Okay, and then we're going to recall display phrase. And that should be our entire class. Now, here's the moment of truth.
Drum roll, please.
Did I goof anything? Yep, I goofed something somewhere, and I bet I know right where it is because I tend to do this. For whatever reason, I always forget that second parenthesis.
Oh, yeah.
Doesn't matter what if statement I'm doing. If there's a set of parentheses inside the if statement, I always forget that outer parenthesis. It's just a bad habit. Okay, so we'll do that. And what I miss? Oh, whoops, letter to check, not letter to guess. Thank goodness for compilers. There we go. Okay, so now I'm going to go over to our simulator. We said that our initial phrase that we're going to look at is the quick brown fox jumps over the lazy dog. So when we first call display phrase, it's going to display all of our words disguised. Okay, now I'm going to ask for a single letter. Do you have a letter preference, Mrs. Westerland?
Let's do J for Jill.
J for Jill. Okay, so we have our J. And I can just kind of keep working through letters. If I do G, if I do E, if I do Q.
There's not a lot of repetition. There's 2 O's. No, there's 3 O's.
Yeah, the vowels.
It's a great phrase.
E and O
check.
are a good one. Yeah.
Mm-hmm.
So yeah, I mean, I can go through pretty much the whole alphabet. T, H, E, U, I, C.
I hope y'all love this project because I love it. I can't wait till school next year to do this project with my class.
Well, and like I said, I mean, it's kind of a quick one. It's one that you can do in a hurry if you just want to kind of go through the class. But like you were saying, you know, there are so many other things you can add to it.
Yeah, we've brainstormed some of that to share with y'all too.
And then at the point where I feel like I know it, I can just say stop. and it'll come up and it'll display the whole phrase because I've got it set down here at the bottom to
Oh, that's
display
another
the
thing you could
display
add
the
is
answer.
type in the phrase you think it is and then
Yeah.
check to see if you
Yeah.
win or not.
So then you can use dot equals to compare your guess
Yeah.
against the actual string. So there's our little game. So play with that a little bit. It's something that you can kind of play with maybe after you've coded it. You know, get your little brother to play along, or your parents, or whoever happens to be around. Have them test it for you. Play it a little bit, and then again expand on it, add to it, see what you can do to it. And you know, make sure you share with us. We love hearing from you the different things that you're doing with the things that we do. So make sure you send us some examples of add-ons and little bells and whistles that you added to it to make it a little more involved. Okay. All right.
Nice.
That's fun.
Nice. Very nice.
I tell my students it would be really cool if we could just sit and code stuff all day. That's the fun part. Okay, so we're back. Is the presentation back up?
Yes, yes.
Okay.
You're all good.
So here's our check for understanding. We're going to take a look at question 3 from the 2017 exam. So I'm going to give you just a second to read that while I get my screen squared away here. Make sure I'm keeping track of time. So take a couple seconds and read it, and then we're going to walk through and we're going to do part A. So I'm going to give you, again, kind of looking at this as if it's our one of our free response questions. Take just a minute, because again, I know time is going to be short on the exam, whether it be the 25-minute question or the 15-minute question. You know, we don't want to spend half of our time just reading the question, but take at least a minute to go out and read it and make sure you know all of the details and all of the important little pieces. And then we'll go back and we'll kind of break it apart together. Okay, on your mark, get set, go. I always feel like when I'm coding in front of my students, it's like my Bob Ross moment.
It was gorgeous.
Oh,
You're
well,
gonna
thank
have
you.
to. It was fabulous. Like,
we had
I'm
some...
sure I'm gonna speak for teachers out in the wild blue yonder and say that they're drooling right now, and they're probably thinking, "Oh, I can't wait for school to start. I'm gonna do this with my class."
That might be a bit of a stretch, but hey,
Well,
we
I
had
think
some happy little
because
instance variables out there, and
I don't know. I remember my grandmother watching Wheel of Fortune, and
yeah,
so it's always a happy memory.
yeah,
So,
yeah,
you know, if you can connect to something that was happy,
yeah. So about 15 seconds left, everybody.
we could call it Spiel of Fortune Cookie.
Oh, there you go.
I know.
Oh yeah, and then you get every phrase could be some little like a
Uplifting,
uplifting
point to
something.
ponder.
Yeah.
Yes.
You will meet a tall stranger. Something. I don't know.
That's not a good point to ponder.
That's
Unless
true.
you're a young
that's true.
person waiting
Yeah.
on Prince Charming.
That's always the one that comes up in the movies, though. You're going to meet a tall, dark
That's right.
stranger. Yeah, I don't know.
You're going to receive money in the next week.
Yeah,
That's
there you
the
go.
fortune that we
Yeah.
all want.
But not from, what is it, the Persian prince or whatever that one is.
No.
Okay.
No.
All right. Hey, before this spins out of control. Okay. So looking through the different things with our question. Now I'm all thinking like money and stuff. Anyway.
Back to phrases and nth occurrences.
So the first thing they give us, they tell us that we have an instance variable that has a current phrase and we have a constructor. Okay, then there's this kind of an unknown. We have this method in here, find nth occurrence, that takes 2 parameters. It tells us that it returns the index of the nth occurrence of string, but it says implementation not shown. So right off the bat, that should be kind of a big red flag, you know, ding, 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 ding. This is going to be something that we have to use somewhere as we finish this problem. So we're going to put a little box around that and hold on to it for later. Okay. We look at the first method that we actually have to write, replace nth occurrence. It says that it modifies the current phrase by replacing the nth occurrence of str with REPL. So we're going to look for whatever the nth occurrence is of whatever they pass us as our first parameter, and we're going to replace that with our last parameter. Okay. And then part B says we have to find the last occurrence of some string. Okay. So those are kind of the biggies. All right. whoops, jumped too far. The second page of this just gives us some examples. So this question, part A, was spread across a couple different pages. So for the second page, they give us some examples, and I've got one of those examples kind of broken down a little bit. We're going to look at this example where it says the cat ate late, and it says we're supposed to replace the first occurrence of at with rain. So as we look through, the first thing we have to do is we have to figure out the location of the first occurrence of at. Okay, well, hey, that's where we can use this find nth occurrence method, because when I tell it to find the first occurrence of at, it's going to return 3. At occurs at position 3. And from there, then we can start looking at, okay, well, how can I do the replacement? Well, we've talked about concatenation. Mrs. Westerland has explained concatenation to us a couple times over the past couple days. So now I can use substring to break this apart into smaller strings. My first substring is going to go from 0 up to wherever I find my first occurrence. And then the second substring that I want starts after the occurrence of what I'm trying to replace all the way to the end. And what I can do with that is now I can use concatenation to take the first substring plus whatever our replacement is, plus the second substring, and I can chain those together to create a new string. Okay. The one last page, and this is the one that doesn't look like there's a lot here, but there's some very, very important information to this. The first thing it tells us is the phrase class includes the method find nth occurrence, which we've already kind of put our little box around, which returns the nth occurrence of a given string. And this problem explicitly says you must use find nth occurrence appropriately to receive full credit. So not only is it there for us to use, we have to use it. If we don't, we're going to lose points. Okay, so you know, I remember this question from the reading, and I remember that there were a lot of students that missed points because they took the extra time to go through and write their own code inside replace nth occurrence to find the nth occurrence, and they didn't use the find nth occurrence method, which was there for them to use already. So even though they did extra work, and they might have even done it correctly, they lost points because this problem specifically says you have to use the method that's there. So be careful of things like that. If you get extra methods in a class, there's a pretty good reason for it. Usually it's because you have to use it, okay? So again, kind of just thinking about our design. We're down to about 10 minutes left. Tell you what, I'm going to give you about 30 seconds to kind of flesh something out on your own before I give everything away. I don't like giving too much away up front. I like you to think about it a little bit first. So I'm going to give you about 30 seconds just so, again, we can kind of stay on top of our time. See what you come up with. Okay, that's probably been about 30 seconds. So if by some chance you're watching a recording of this and you need a little more time to kind of finish kind of fleshing out just a quick design, feel free to pause. Take a little time and actually take the time to kind of think about logically what the steps are before you press play and go on, so that you actually get the experience of kind of thinking about how this is going to work out, okay? So first thing we need to do is we're going to find our nth occurrence of str given n, and I specifically wrote that method out, even though this is pseudocode, because we have to use that method as is, and whatever it returns, we're going to store in a variable called loc, or location, or you know, whatever you would like to call it. Then for our design, if the location we just got is valid, in other words, it's not -1, then we can go through and we can build our substrings and repeat or construct this new current phrase. Okay, so we've got this variable current phrase, but you know, whenever we remember that Mrs. Westerland pointed out at one point that strings are immutable, they can't be changed. So technically, we're not changing current phrase. We're totally eliminating current phrase and replacing it with this new version of current phrase. Okay, so that's something else that sometimes my students have had a hard time kind of wrapping their head around. If I change something to uppercase or change something to lowercase, or I replace something with, you know, a substring, or if I concatenate a character onto the end, I'm not changing the string that's there. I'm taking that string, adding something to it, and then totally replacing the original string with this new string that I've just built. So it's kind of a distinction that you know, I have to remind my students of from time to time. Okay, so there's our basic design. That's pretty much it for part A. So now let's kind of look at the code. So if we were going to go through and code this off of our little roadmap that we put together, you know, we have our declaration and we want everything to be proper Java code at this point. We're going to do int loc equals find int occurrence of str in. If loc is not equal to -1, in other words, we found something, it gave us a location. That means we found whatever occurrence we were looking for. Now I can go in, and you can do this in a couple lines of code like I did up here. You can do it in one line of code, but we're going to find our first substring that goes from 0 up to the location that we identified. We're going to find our second substring that goes from location plus whatever the length of str is. And then we're going to concatenate them together so that we end up with a brand new string that has REPL, this piece that we're replacing, right smack in the middle. Back to the Oreo cookie example. So we've got the 2 cookies and we've got the cream in the center.
We're all ready for a snack, apparently.
We definitely are. I love Oreos. Okay, so that's our lesson for today. Today it was all about creating algorithms and writing code, and hopefully you enjoyed the live coding. I need to do more of that. I like doing the live coding stuff as opposed to just walking through PowerPoints. So
yeah.
So we're ready for our tip of the day.
Yeah, and I hope you're inspired to do some mundane things with strings and kind of see how to make them come alive in real life samples. Okay, so tip of the day, we're to the day 4 of our different ways to use snipping tool, and today are our Mac folks, the passionate Mac users among us. Control-Shift-4. I had to text a former student, Lindsay, who's now a software engineering major, and I know she's a Mac person, and she sent me back this. I made my slide and then I sent it to Lindsay and said, did I do it right? And she said yes. So on a Mac, this is how you snipping tool, and it saves it to your desktop, Lindsay said. So that is kind of a nice place to save, easy to find. So you should now know how to snipping tool from something, from any kind of device that you have. So we hope that's helpful to you. I know it's a life skill. All right, so yes.
I was just going to say every non-Mac teacher needs a Lindsay.
Oh my gosh!
Because I have students that'll ask, well, how do I get this to install on a Mac? And I'm not a Mac guy. If I have one in front of me, I think I could figure it out. But
when she was in CSA, she made me a set of directions for downloading and setting up JGrasp on a Mac.
Oh, nice.
So if anybody needs that out there, I'll have Lindsay's notes. Okay, so your power up for today is to work on your projects, work on your like independent coding. You've got like 5 options now up there at the top. We're trying to inspire you with projects that are meaningful. So word in a word, password creator, the name that string activity, wheel of fortune. And if you think about it, make a fun video and share it on probably Twitter or TikTok or something that we could see on a hashtag. And then you need to also finish 2017 Part B, and we'll go over the answers to that tomorrow. And how much time do we have? All right.
We've got
if we get to
about
the
2 minutes.
Yeah, I've made a new document along this line. I was going to grab the screen and show it to you, but it's not important. There's a new folder. It starts with an exclamation point, and it's called Recommended Projects. So I'm going to try to catalog here some of these projects that we recommend that you work on. Please don't be bored at home. Use this time to sharpen your skills, and that way you won't have to dig through all the different power-ups. And if you're a teacher and you're watching us, we'll build a project bank that will help us all in the future. We'll have, I'm trying to catalog them by when they were presented here, so you'll have the video date, and then maybe I'll get fancy and use links, and then also what unit from the CED they go with. So we'll have some good projects for the future. Okay, so that's your homework, and here's our show and share. Is that dog not precious on the left?
Oh my gosh.
I know. Aspen Sadie. And then I think that the thing in the middle is an original meme. It's quite a choice. Do I look at cute puppies or do I do coding Matt? Anyway, Bo and
Riley,
JJ would choose the left, the blue button.
I'm going to steal that and actually make that a poster in my room, I think, at school when we finally get back. So Riley, I love that.
I know, it's so cute. The person behind it, my personal students, I showed them this on our class meeting, and they told me where the person. It's some kind of like big-headed little cartoon character. I think it might be trademarked or something, so I hid it.
Okay.
But if you know what it is, then you'll think it's cute. And then I love these. Are they French bulldogs? I forgot what
Oh, I
kind of
don't know.
dog that is. My
I don't
neighbor
know.
has a mixed breed of similar of that. So cute little Jack from Miss Sparks in Edmond, Oklahoma. So
Keep the
that's
pictures coming. We
I
love
know,
seeing the
love it.
pictures and the memes and all that good
I
stuff.
know. Sometimes the memes are we're afraid we'll get in trouble in terms of trademark or copyright. So but they're great.
But we
Um
enjoy them.
That's exactly right. Um, okay, again, if you need tech help, the clock is ticking. You cannot wait until like May the 13th to contact about this because they're, might have to ship something to you. So cb.org/tech if you have a need. If you have only a phone or you have only a tablet, then I'm talking to you. Contact this cb.org/tech and see what is available to you for support. We would like for you to have more than a phone or a tablet to take your AP assessments on. It can be done that way, but it would be a little bit of a disadvantage. So we want you to do that. Along the same line, I have another note over here, my sticky note collection. If you do not regularly get email from College Board, um, it would be a good idea since AP Classroom is available to you for you to go and look at your settings in AP Classroom and check the email address that is there and perhaps think about using an email address that's not associated with your school email in case it could be getting caught in some, filters that your school might have set up. So use maybe a personal one. You might be hearing that from your teachers and AP coordinators in the next few days. So check that. And we are so happy you're with us. I know you love today because our spiel of fortune cookie is amazing. And come back tomorrow for whatever it is we're doing tomorrow. We're doing a little more strings.
Tomorrow we're looking at
Equal, compare
comparing the
to,
difference
yeah.
between equals, equal, dot equals, and compare to, and we'll kind of dig in depth about what happens behind the scenes with some of that
And
kind of
I'm
stuff.
already getting excited about array lists on Monday. I'm already brainstorming. So
Keep coming back.
that's right. See you
All
next
right.
time.
Yep. We'll see you next time.